So 3.3 and 4.1 if we can. If we can. See. It's long division. So the rules that govern long division from long ago, far away, your past, are going to be the rules that are going to go determine your long division for something like the polynomials. This is where we're going. This is what you'll have to do. You're going to do something with long division on a problem like this. And then we're also going to learn a technique called synthetic division. Okay, synthetic division. You can't do synthetic division. It's a wonderful way to do division. It's really nice. But you can't use synthetic division unless it's in a special setup. Only in certain setups can you use synthetic division. Good news. You won't have to worry about making that choice. I'll tell you, do this problem, long division, do this problem, synthetic. Now, when you move out into the real world, you can make your own choices. But we need to know how to do long division if you're going into calculus. Because there are things that we cannot do in calculus the way it's written. So we have to do long division on it so we can do it. We test things. Does something work with synthetic division? Also known as synthetic substitution. Okay, so these techniques are going to help with other things in other classes. Now, I'm sure I would not hit to calculus. Hey, you're coming along for the ride. The dividend divided by, that's the divisor. So I'm going down over there. Dividend divided by the divisor equals the answer called quotient, and you have a remainder that you write over the divisor. When we convert it to long division, the dividend is underneath and the divisor is on the outside. How many times can 5 go into 564? Now, I would say a long time ago, 5 years ago, we used to teach arithmetic. And then the law got involved. And they said, you know what? We're not going to teach arithmetic. And it was a remedial class like arithmetic. And that's not the right word with remedial. I understand why it's called remedial, because everybody should be, your college should be beyond arithmetic. So I get it. But you know what actually it really is? It's a foundation class. You cannot do what you're doing right now unless you have the foundation to do this. You can't do what you're doing right now unless we have algebra 1 to do this, to do that. And algebra 2 to do what we're doing. And the reason why we're not going as quickly as we can is because we're doing a lot of the algebra 1 and the algebra 2 teaching that is missing in your memory banks. Or maybe it's in the deep, dark recesses that you don't want to go to. In that closet in your head that you just don't want to open. When I taught the arithmetic classes, they were full. And those students went on to algebra. They went on to algebra 2 when we offered them. And one of them went on to trig and kept moving. We're not allowed to do it. Do we start here? The reason why people don't get this right is because they're sloppy. It's about place value. So when you get to those, it's about place value. Making sure your place values line up. You go one place at a time. You start right here in the 5. This is the hundreds place. So you start right here above the 5 in the 100 place. So it lines up. And you just ask yourself one question at a time. It's one thing at a time. How many times can this 5 go into that 5 in the hundredth place? One time. Remember, this is no calculus because you're not going to be able to do a calculator on that. So it can go in one time. So in the hundredth place, we get a 1. So 1 times 5, right underneath, we get a 5. Since this is in the hundredth place, this is technically 500. Because this would be in the hundredth place, that's 100. What's the next step in long division? We subtract. So when we subtract, we get 4 minus 0, we get 4. 6 minus 0, we get 6. And 5 minus 5 is 0. So we're left with 64. So now we're looking at this from the perspective of that's a 6. From the tens place, 1 place over. In the tens place, that's a 6. How many times can 5 go into 6? Once. So in the tens place, we have a 1. So that's a 5. In a tens place, that's 10 times 5. So it's technically a 50. And then you subtract. 4 minus 0, we get a 4. 6 minus 5, we get a 1. We can't go into the 10th place anymore. 5 into this 1. We're done in the 10th place. So now we're in the ones place. In the ones place, we're looking from the perspective of a 1. We're looking at a 14. 14 ones. How many times can 5 go into 14 ones even? 2 times. 2 times 5 gives me 10. And then we subtract. $14 minus 10 is a 4 in the ones place. Now here's the most important piece. Once you get to the ones, you can't go any further. It would be decimals, but we're not going to go decimals. We're not going to go decimals with that. So what we do is we first learned you went 112 and then you put remainder 4. But that's not it. We're going to go plus the remainder, which is 4, over the divisor, which is 5. You wouldn't do it with numbers. What we actually just did when you look at it from the perspective of where we're at now, division is a fraction. So this would be an improper fraction, 564 divided by 5 or over 5. And what we just did was convert it into a mixed number. 5 goes into 564, 112 times evenly, with 4/5 left over. 112 and 4/5. That's how you convert it into a mixed number. You do the division, you put the remainder over the divisor. We don't need the plus when it's just numbers. When it's variables, you have to have the plus. You have to have the plus. But when it's numbers, you wouldn't put the plus. We never did before. Do you know how to go from 112 and 4/5 to change it back into the improper? What do I multiply? So 112 times the 5. And then what? You add the remainder into that back over the 5. So you multiply here because it went in. 5 goes into this 112 times. So you multiply it back out. The remainder is what was left over. So you add it back in. 5 times 112 is 560 plus 4 over 5. So that's 564 back over 5. That's how you would convert it from a mixed number back into the improper fraction. Hopefully it's ringing a bell. Okay. So place value. So let's look at place value again. 564 divided by 55. So 55 is the divisor and 564 is the dividend. And look how important it is to kind of space your numbers out because you know you're going to put something underneath. If I write it like this, which I see some of your handwriting will look like that, it's like, okay, I'm going to subtract 55 somewhere. It's like, I don't know what you wrote. I really don't. I don't think you do either. 564. Some of you actually focus on cleaning up what you're writing. You'd be surprised how much better your grade would be. You really would. Because you'd have to be more focused as you did it. That's the only way you'd have to clean it up is you would actually have to focus on what you were doing. You would have to slow down as you did it. You'd have to think a little bit more before you did it. All of those things are like dominoes that might fall into place to help you get it better. So right here, you look at the very first place type, 5. Does 55 go into a 5? No. So then you go to the tens place. Does 55 go into 56? How many times? 1. So now the answer is going to start here in the tens place. It starts right above the 6. Here's the important piece. Since I'm starting in the 10th place, the next number that could possibly work would be in the ones place. So my answer can't be 100 anything. It's going to be at the most 10, maybe a 10, between 10 and 19. Somewhere between 10 and 19. That's all I have. So from the tens perspective, this is a 55, which means it's a 550. 4. 6 minus 5. 1. 14. So now you're at 14. 14 is 55 over 14. And that's important because it doesn't go in, so people just stop. And they write the answer as 1. No, it's not 1. You know it's not 1. Hopefully you know it's not 1. But what happens is because it doesn't go in anymore, they just stop. And they don't fill in the rest. If they didn't put it in the tens place to begin with, when you ask yourself this question, how many times can 55 go to 14? Since it can't, if it can't, it goes in 0 times. Because you have to have something in the ones place. So 55 goes in 10 times with a remainder of 14 over 55. So 564 divided by 55 would be 10 and 14 55ths. Oh, we're in that place value, one place value at a time. If I don't start right here above the tens, and if I just write a 1 anywhere, I won't know I'm in the tens place. And that's the sloppy work that people started when they first did division. They just put it anywhere above on the division side. And whatever elementary school teacher they had, they've got 20 students, 25 students, they're just hoping they're getting something down. They're hoping they're getting something right. They're not checking to make sure all the place values are correct. Not to mention, a 4th or 5th or 6th grader's handwriting is just as worse as some of the handwriting I deal with. It hasn't gotten any better. Place value. That's what matters. It's got to line up. One place value at a time. So 502. His input. 51,709. So start with the 10,000s. 502 doesn't go to a 5, so there's nothing above the 5. Then to the thousands. 502 does not go into 51, so there's nothing above the 1. There's nothing in the thousands place. So we go to the hundreds. Right above the 100, the 7. That's 517. How many times can 502 go into 517? Once. So in the hundreds place, it'll go in one time from the hundreds point of view. So 1 times 502 is 502, and it terminates in the hundreds place. And you fill in the zeros. So if this is 100, this would be 50,200. Okay. And then you subtract. 9 minus 0, we get 9. 0 minus 0, we got a 0. 7 minus 2, we have a 5. 1 minus 0, we have a 1. Then you kind of, again, I always tell you to think ahead. Just kind of picture what the next move might be. We're in the hundreds. You only have 2 place values left to worry about. Since we're starting in the hundreds, we're going to end in the ones. That's a given. So the stress level's got to decrease because you know that was a big number, that's a big number, but we're starting in the hundreds, so we only have 2 place values. So now we're in the tens, right here above the 0. So we're only looking at 150. That's all we care about, the 150. So you look at 502. Does 502 go into 150? No. So 502 goes into 150 0 times. So in the tens place, we have a 0. In the tens place, there's a 0. Then you can go to the ones. Now you're looking at 1,509. 502. Let's just kind of estimate. Let's say this was a 500 and that was a 1,500. Let's just say 5 and a 15. So let's think. We're going to try a number. There. Yeah. I make my dad noises whenever I have to like get up from the chair and get the bend up. And he was a roofer. I've been a teacher for 40 years almost now. I'm going to tell you. Okay. So 5 and a 15. What number should you try? 3. I mean, you have choices. 1, 2, 3, 4. 4 times 5 would be 20. That's too big. 3 times 5 is a 15. I would try that first. And so back in the good old days, 502, test it, 3, 2 times 2, 6, 0 times 3, 0, 5, 15, 1,506. So that'll fit. So we're going to use a 3. 3 times 502 is 1,506. And then we subtract. And we get 9 minus 6 is a 3. 0, 5 minus 5, 1 minus 1. Remainder is 3. So plus 3 over 502. So this divided by that is 103 and 3, 500 over 2, 502,000. Long division. Yeah.
How important is that plus sign?
For numbers, not important at all because it's a mixed number. When we do the variable, like we're going to do right now,
Then
It is, because if you don't put it, it's multiplication. Now, the destination that we're headed to is the first example for 3.3. We're not going to start with, we're going to start with something a little simpler. Back to the x to the third, we're just going to start with a simpler x squared. X squared, let's go with plus 9x minus 4. That's no, minus 9x plus 4. And we're going to divide by x minus 3. First, are those parentheses important?
Yeah.
Absolutely. Why? Because I put them. Everything I do is more important than everything anybody else does. Okay. No, that's not because of. Watch what happens if I take the parentheses off. Let's just take these parentheses. Okay. If I just take the first set of parentheses off, you know what this is? This is actually x squared minus 9x plus 4 over x minus 3, because it's just the 4 divided by 1, not the whole thing. If I leave the first parentheses but take the second one off, then this problem is x squared minus 9x, the whole thing. We're dividing it by x, and then we take 3 away from it, order of operations. Different problem. If I take both of the parentheses off, then order of operations, this is actually x squared minus 9x plus 4 divided by x, and then a minus 3. Another completely different question. So if I want to take this polynomial, the whole thing, and divide by that binomial, the whole thing, they both have to be in parentheses. Without the parentheses, you don't have the same problem. Now, this as a fraction would be x squared minus 9x plus 4. All of this is divided by an x minus 3. That's what it looks like as a fraction. So remember, this goes on the outside, divisor, and then underneath is the dividend. So on the outside is x minus 3, and it's going to go into x squared minus 9x plus 4. I don't have to put the parentheses when I rewrite it, because now the whole thing on the outside, the whole thing here is x minus 3 going into this whole thing. Here's how it starts. The only thing you care about is place value. And the place values you have a place value of x squared, a place value x to the first, a place value of the constant. Those are your place values instead of hundreds and tens and ones. Your place value is determined by the powers. Okay, the powers. You want to make sure things line up. When you make your decision, when we did numbers, you looked at this number on the outside, you looked at this number on the inside, in the hundredth, can it go in? No, then you went to the tens. All you care about, the only thing you look at, what matters the most, is this first term and that first term. That's the only thing to look at. And the question you're going to ask yourself, you want x squared, you have x, you want x squared, so you have to ask yourself, what times this x is going to give you x squared? I need x squared, I have an x, so what times this makes an x squared? I have to multiply by an x. So x times this x will give me the x squared that I want. Because you got to figure out the quotient, what times this equals this? What times this equals this? So what times x make x squared? I need to multiply by x. You don't care about the -3 when you make the choice. You don't care about the -3 at all. We're going to use it, but we don't care about it when you make the choice. So I choose x. It's an x to the first. X to the first goes here. My x to the first are in this column. Plan ahead. Look, I only have one place value left to go, the constant. Going to start with x. We're going to finish right there. The rest would be a remainder. Okay. When we did division, and I have 502 into was it 50, I don't know, 52,000, I don't know, 51,709. Okay. And we made our choice right here. We did 1. We took the 1 and we multiplied. We took the 1 and we multiplied. We took the 1 and we multiplied. So now you take that x and you're going to multiply times the divisor. You take this and multiply here. We took the 1 and we multiplied here. So now, since the divisor is 2 terms, you distribute. And we get x squared minus 3x. So what determines your choice is just what's this first term, what's that first term. How do I make x into x squared? I need to multiply by x. So there's my choice. So now multiply. X times the divisor. X times x to x minus 3. I get x squared minus 3x. What's the next step in long division? We subtract. The next step is you would subtract. Same thing here. You're going to subtract. All right. This is where I would usually throw a fit. If I'm going to subtract, I would have to subtract the whole thing, which means I better put parentheses. I've been trying to get you guys to put parentheses all semester long. Sometimes it works, sometimes it doesn't. So here's the deal. If I put parentheses, what's this negative going to do? It's going to distribute. And when the negative distributes, it's going to look like this. You're going to end up subtracting each one. So just subtract each one. Subtract, subtract. Everybody's going to get subtracted. You get subtracted, you get subtracted, everybody's going to get subtracted. The whole purpose of choosing this x times this x is so these two add up to zero. So if this doesn't make a zero, you chose something wrong. Talk about Indiana Jones, The Last Crusade, you chose poor. Indiana Jones was an archaeologist and discovered lots of things like that. Yeah, commandments and Holy Grail and Temple of Doom. Then he found skulls from aliens, which is really bad. And a time device of, time machine about who would have it. X squared minus x squared 0. Look what happens here. Negative 9x minus negative 3. What happens when you subtract? That becomes plus. That's why I want you to go minus and subtract each one. And when you have subtracting the negative, it becomes addition. So you can see it. Not this. And this is where it becomes like I show you what I want you to do, and then they go, okay, we're going to minus and that becomes plus. They don't do the subtract. And so I'm looking at them, they messed this up because now they go over here and they go, oh yeah, I'm supposed to subtract it. So they go back and then they change it back to a negative. They go, oh yeah, I'm supposed to subtract it. So it was a positive, forgetting they already changed it. So it's like they're one step ahead, but they went 2 steps behind. So just be patient. So subtract each one. X squared minus x squared 0. Good. And then when you subtract this negative, now we get a positive. Negative 9x plus 3x is negative 6x, and then a plus 1. And then, of course, you do it again. Sealing down. That would be very bad. You only care about this first term. You only care about this first term and this x. That's all you focus on. That's all you care about. Because you want to make it a 0. So your next choice right here, and you're in the constants column. This is the last thing you have to pick. What times we have an x, this x right here, we want negative 6x. We want negative 6x because that's what we have to cancel out. So what times this x would make negative 6 times that? Negative 6. I need a negative 6. I want to make this negative 6x. I have an x. So what times this x makes this? That's going to be my next term. Need a negative 6. And all you look at is the first term here and that first term there. The negative 3 and the 4 don't matter. They will be taken care of when you multiply. So since we've chosen negative 6, it's now the choice times what we have. We got to multiply. But just making the choice isn't good enough. You now actually have to use that choice times the divisor. Negative 6 times that x minus 3. Distribute negative 6x. Negative 6 times negative 3. That is our sign there. Positive 18. This is now negative 6 x plus 18. Any questions up to there? And subtract. Subtract each one. Negative, no, this better make 0. Negative 6x minus a negative, so that becomes a positive. Negative 6x plus 6, that canceled out. That was 0. Just like we were supposed to have. So we did good. Okay. And then 4 minus 18. We don't have two consecutive negatives, so it's just 4 minus 18. So 4 minus 18 is negative 14. That's the remainder. We're at a constant, so we're done with the quotient. You're not going to have to pick anything else. And that's because x can't go into a 14 because it doesn't have an x. Anything I would multiply times this x would have to have an x here. It doesn't. So we go plus. You have to go plus, and you still plus the remainder, negative 14 over the divisor, x minus 3. And that's how you should leave it. Some of you are going to be so tempted to write it like this. And that is not wrong. Because what happens if you add a negative number? Plus and negative is just subtraction. But I'm imploring that don't risk it. You had the right answer. If you make a mistake, now you have the wrong answer. So just write it plus and then whatever your remainder is over the divisor. Always just use plus. Okay? That'll work every time. You have to have the plus because without the plus, if I don't put plus, if I write this is 6 times this. Now, if you don't have anything in between, then that's automatically multiplication. Because we don't have mixed numbers with variables. So you have to have a plus because it's added on to the polynomial. So you have to have a plus. Okay. So there's our destination. And this one is an x to the third. And it's a 6x to the third. Got a whole bunch of stuff. I want to point something out. The problem could be asked like this. 6x to the third minus 19x squared plus 16x minus 4. Remember, division means it's a fraction as well. I can write it as over x minus 2. Same thing. So the divisor's on the outside. And the dividend goes underneath. When you rewrite it, you want to rewrite it neatly. And then you begin by looking at just the first terms. This first term, x, and that first term, 6x squared. So you're looking at x, what times an x makes 6 and an x to the third power. So just focus on, I need a 6. So I'm going to have to multiply by something that has a 6. I need a 6, so I got to multiply by 6. Because right now I just have a 1x. I need a 6x. So I need a 6. And then I have an x, I want x to the third. So what do I need to multiply x by to make x to the third? X squared. So the very first term of my quotient is 6x to the second, 6x squared. And it should go right in the column where the x squareds are. So you know the quotient is going to start here, the x squareds. You only have two more terms that you could possibly work with. You distribute 6x squared times these two now. 6x squared times x minus 2. Now I got to multiply. 6x squared times x is 6x to the third. 6x squared times negative 2 is negative 12x to the second. Asking if you got it. Then we subtract. Subtract each one. That better make 0. It does. 6x to the third minus 6x to the third. 2. Negative 19x squared minus it. That makes a positive. Negative 19x squared plus 12x squared is negative 7x to the second. And then bring everybody else on down. Plus 16x minus a 4. And then we go all over again. We have an x. We want negative 7 x to the second. So all I have is an x. I want the negative 7. So I have to multiply. Definitely going to need a negative 7 because right now I just have a positive 1. I need a negative 7 to get that negative 7. I have x to the first. I want x squared. So what is this going to be? Next. So the next term, and it should be, look, I'm at x squared. The next term should be an x to the first. One column over would be an x to the first. So it would be a negative 7x. Right here, minus 7x.
Question, you know, you have x to the second and both of those. We never touch those. It seems like, right?
Well, right here, yes. So say it like this. I have negative 19 of these x squares, and negative 19. And I'm going to take away, I'm going to add 12 of these x squares. So if I have negative 19 of them, and then I add 12 of them, how many x squareds do I have? I have negative 7 of these x squared. So let's say I owe you 19 cherry cokes, and I pay you 12 cherry cokes. So how many more cherry cokes do I owe you? So I owe you 7 more cherry cokes. The cherry cokes didn't change. The x squared doesn't change. Because that's what we're adding. We're adding up all the x squared that we have. How many more do we have left? Okay. And that's why it maintains the x squared polynomial. Here's where you can be. Here's where I hope you end up. You don't have to do it on the side. If you have to, that's fine. I'm going to do it on the side as well. But once you make that choice, you know you're going to distribute. So you have a negative 7x times a positive x. So a negative times a positive would be a negative. X times x would be a 7x squared. Then you have a negative 7x times a negative 2. A negative times a negative, that would be a positive. 7x times 2 is 14x. So you don't have to write it on the side where you have negative 7x and distribute. You don't have to. But if you need to, please do. Negative 7x times x. Negative times a positive is a negative. 7x times x is negative 7x times x squared. Negative 7x times negative 2. Negative times negative, that's a positive. 7x times 2 is 14x, positive 14x. But it's distribution. What's the next step? After I multiply, what do I do next?
Subtract.
We subtract. So you got to subtract each one. This better make a 0. Negative 7x squared plus 7x squared is 0x squared. This is just subtraction. 16x's take away 14x's is 2x's. So where the x squared we started, x to the first, the last column should be the constants. So I have one column left to go. And then we do it again. You care about this x only, and you care about the 2 only. So you're looking at, we have an x, we want a 2x. So what are we going to multiply this x to make a 2x?
Positive 2.
We need a positive 2. 2 times 2x, sorry, 2 times x equals to 2x. So this last term should be a positive 2. Plus 2. So this 2 times an x gives me a 2x. Make sure you take care of your sign. Positive 2, that's a negative 2. 2 times that's a negative 4. And again, you would just take that 2 times the divisor, the whole thing, distribute. 2 times x is 2x. 2 times a negative, negative, 2 times 2, 2x minus 4. And then subtract again, each one. 2x minus 2x is 0. Negative 4 minus a negative 4 becomes plus. The remainder is 0. When you have a remainder of 0, that means it goes into it evenly. When you have like 8 and you divide by 4, you go 4 goes into 8. How many times? 2, and the remainder is 0. That means 4 is a what of 8? It's like a 6-letter F word. It's a factor of 8. It goes into 8 units with a factor of 8. If x minus 2 goes into this evenly, that means x minus 2 is a factor of 6x to the third minus 19x squared plus 16x minus 4. Which brings me to one more little piece. X minus 2 goes into this evenly, so x minus 2 is a factor. Watch what happens if I multiply both sides by x minus 2. I'll put it in front. Not only is x minus 2 a factor, plus sign. Not only is x minus 2 a factor, But because these two multiply together and equal this, 6x squared minus 7x plus 2 is also a factor. Since they multiply together and equal this, they're both factors of this. Since 8 is equal to 2 times 4, both the 2 and the 4 are factors of 8. So since these two multiply together equal this, these two are both factors of this. Now, I wouldn't ask you to factor this like that, but using long division is a way to test for factors. Now, there are methods to determine simple factors using Descartes' rule of signs and the rational root theorems that allow you to basically pick out the possible rational roots that might actually divide into it evenly. That uses synthetic substitution to figure out what works quickly. Yeah, just when you think you've reached the top of a mountain, it's just a hill hiding another mountain. We got roots. Always looking. We just did this question here. And we did something like the one below. Language. You gotta watch your language. This is where you go. This is why I have a job. So you don't have to read the textbook to yourself. If f of x and d of x are polynomial such that d of x isn't equal to 0, then the degree of d of x is less than or equal to the degree of f of x, then there exists a unique polynomial as q of x and r of x such that f of x is equal to d of x times q of x plus r of x. Functions. This function f of x, the dividend, is equal to the divisor times the quotient plus the remainder. F of x divided by the divisor, whatever the divisor is of the polynomial. We get a quotient q of x plus a remainder written over the divisor as function, as with x's, polynomials. We get a quotient remainder over the divisor. Now, it's just a function if I multiply both sides or each term by the divisor. So the function by itself is just the divisor times the quotient, which is what I just did on the last question. There was no remainder, so this was 0. So when it is, it's just plus the remainder. I don't want you to worry about that language. What I need you to be able to do is do long division. That's what I need you to be able to do. But that language is what gets you later on. That's how it's going to be presented without an explanation. All it is just rewriting it in terms of function notation. Nothing to stress about. Instead of writing x squared plus 3x minus 7 over x minus 4, this represents everything and anything that possibly come up. That's it. Before you apply the division algorithm, make sure you follow these steps. This is not going to work unless everything is organized. Which again, when I looked in your test, didn't I say multiple times, keep x squared positive? When you want to use the quadratic formula or you're trying to factor or whatever, you want to keep the square term, keep it positive. Even that means moving two things. Keep the square term. Well, I got through a lot. Write the dividend and the divisor in descending powers of the variable. So you don't want to have things mixed up. You want to go from the biggest power to the smallest power. Everything needs to be arranged correct. If you're missing powers, if there's missing powers, you want to put placeholders with zero coefficients for those missing powers. Otherwise, we're not going to have place values line up. So here's the examples. X to the third divided by 2x minus 1. I'm going to do this wrong, so just watch, don't copy it down. If I try to do this without fixing it first, the divisor is 2x minus 1, and I'm trying to divide into 8x to the third minus 1. So I have 2, I want 8. What do I have to multiply by? A 4. If I'm not paying attention, I'll probably just put 4. I have x, I want x to the third. So what times x gives me x to the third? And x squared, 4x squared. Now, normally, like I've just been showing you multiple times, I should have a 4x squared lined up over a column of x squareds. I don't see an x squared column. But I'm going to multiply 4x squared times 2x. There's my 8x to the third. There, that's good. 4x squared times negative 1 is minus 4x squared. And then you subtract. That's a 0. That's good. Then we add. And then how am I supposed to take, 4x squared and negative 1? There's no like terms. It's not under the right. If you don't have all the powers, if you're missing exponents, you got to fill them in with zeros. You need placeholders. You should have all the powers. The biggest powers of x to the third, you need to have x squared, you need to have x to the first, and then you have your constant. So the first thing that's wrong is I didn't have my placeholders. So this is going to get rewritten. 8x to the third, I need an x squared. So it will be 0x squared. I need an x to the first, so 0x, and then there's my constant, minus 1. And then divided by x to the first and x to the 0. So I'm not missing any powers here. So I divided by 2x minus 1. Now things will line up like they're supposed to. 2x minus 1. Dividing into 8x to the third, 0x squared, 0x minus 1. Okay, we made our choice already. To make a 2 into an 8, we need a 4. We need a 4 and make an x squared, an x into an x to the third, we need an x squared. So we're going to multiply by 4x squared. X squared should be right here. 4x squared. Which means I only have 2 columns left to go. 4x squared times 2x. 8x to the third. 4x squared times negative 1. Negative 4x squared, and it's right here lined up with the x squared. You got to have those missing powers. Subtract. Same technique, same algorithm. Cancels out. 0 minus a negative becomes a positive. 0x squared plus 4x squared is 4x squared. That's still 0x and a minus 1. We slide over, and we're now in the x to the first column. We have a 2x, and we want a 4x squared. So what times 2x gives me 4x squared? 4 times 2?
2.
2 times, and what else for the x squared?
Thanks.
And you next 2x. So to make for 4x squared with a 2x, I need a 2x. 2x times 2x, there's my 4x squared. 2x times negative 1 is negative 2x. And then we subtract. There's my 0, like it's supposed to be. 0x minus a negative, that's a positive. 2x minus 1. And then I have a 2x. I want a 2x. So what times 2x is 2x? A 1. So I have to have a last term. X squared, x to the first, my constant. So I'm going to multiply this by plus 1. 1 times 2x minus 1. 2x minus 1. And when I subtract, what am I left with?
0.
0. No remainder. So this divided by this is just 4x squared plus 2x plus 1.
Is that the word limit?
What, this right here?
Like, how to solve the problem?
Yes, you do the log division, yeah.
Oh, okay, because it's what it's like not to write it down because you're gonna do it incorrect. Right?
I already did that.
Oh, okay.
I did it incorrectly with, because I did put a placeholder. Then I did it with the placeholder. So this is the present. The other one is an example of what else, it said you have to have it in the right order. So it has to go from the biggest power to the smallest power. So this is obviously just written backwards. It should be 2x to the 4. I'm just going to write it in here for the sake of time. Should go here 2x to the 4, and then my 4x to the third. Then my negative 5x squared, signs matter, positive 3x, and then negative 2. And dividing into that, the divisor is an x squared plus 2x and a minus 3. Now, it looks horrible. But think about it. All you care about, I don't know how many times I said that, all you care about is this first term and this first term. Everything else doesn't matter. I have an x squared. I want 2x to the 4th. So what times? I need a 2, so I'm going to multiply, I'm going to need a 2. I have an x squared, I want an x to the 4th, so I'm going to multiply by 2 times x. 2. I need an x squared. 2x squared times an x squared gives me that 2x to the 4th. So I'm going to multiply by 2x squared. And you know what? It's going to start right here. So as ugly as this looks, it starts here, which means I only have 2 more terms to go. Start right there. Distribute. And again, if you have to write it on the side, that's fine. You have to go, all right, it's 2x squared times the whole divisor. X squared plus 2x minus 3. 2x squared times, that's 2x to the 4th. 2x squared times 2x, that's 4x to the 3rd. 2x squared times negative 3 is minus 6x squared. And we 2x to the 4th
plus four x to the third minus six x to the second. And subtract. Just like the build. This better make zero, and it does. And look right here. 4x to the third minus 4x to the third is zero. That also cancels out. Negative 5x squared minus negative 6, so that's now positive. Negative 5x squared plus 6x squared is positive 1x squared. Bring down the plus 3x and the minus 2.
All right. Think. And I'll just, one second. I'll do a third word. Think. Perspective. You have x squared, and all you want to make is x squared. So you have x squared. And you want to make x squared. The next column is x to the first. If I multiply by an x, what's x times x squared?
X3.
X is
To the third. To the third.
See, another thing is about pronouncing these things correct. X3 is like the third X-Men movie, which is 4, okay? If I multiply by an x, I get x to the third. I don't have any x cubes. What times an x squared is an x squared?
1.
A 1. So you know what? I'm going to have 0 x's that I use. I don't need an x to the third. So the last thing I'm going to need is a plus 1. 1 times x squared is x squared. 1 times 2x is a plus 2x. 1 times negative 3 is negative 3. But that's why you're checking each place up. Okay. Cancel out. 3x minus 2x is 1x. Negative 2 minus a negative 3 is a positive 1. X squared can't go into x to the first. This is my remainder. So on your test at the bottom of the box, you would have, and I would write it, I would probably leave it as is, but you would write your answer 2x squared. You always simplify. What is 0 times x? 0. So 2x squared plus 0 plus 1 is just going to be 2x squared plus 1, and then plus the remainder over the divisor. You would put the 0x in your answer because 0x is just a 0. You would put it. So we got the half. And here's where you go. On the homework assignment sheet, that means 13 through 19, long division. On Tuesday next week, 23 to 29 is synthetic division. And then we will get through all the 4.1 and practically all the 4.3. Have a calculator. Have a good weekend. David, wait, make sure I know and make sure you pick up your stuff.